Hello students. Today we're going to look at the second part of 11-5, which is dividing polynomials. Now when we did dividing polynomials before, we divided by a monomial and divided each term by that monomial and simplified the fraction. The other way we did it was when we divided by a binomial, but our trinomial was always able to be factored into two binomial factors. Sometimes your trinomial is not able to be divided into two binomial factors, which is the case today, and you have to use long division to figure out the answer. So today, none of our trinomials can be factored by factoring into two binomials. So we're going to have to use the long division process. So we have y squared plus 4y plus 12 divided by the binomial y plus 3. Now I cannot find two factors of positive 12 that add up to 4. That's why I can't put it into two binomials. So I have to use long division. And long division looks exactly like what you think long division looks like. So we put y squared plus 4y plus 12 inside the house and y plus 3 on the outside. Okay? So the first thing we're going to do is we're going to just look at the first term in each of the divisor and the dividend, the y squared and the y. So how many times will y go into y squared? And the answer is y, so I just put it right here. Because y times y is y squared, bring that down, and y times 3 is plus 3y. And just like in long division, we subtract. And so I have 4y minus 3y, which is just y, and y squared minus y squared is nothing. So I'm left with y. And just like in long division, I'm going to bring the 12 down. Again, I'm only looking at the first term. So I'm going to see how many times will y go into y. And that would be 1. And so I'm going to put plus 1 because they're both positive. So 1 times y is y, and 1 times 3 is 3. And so I subtract them. Put a subtraction sign there. And so y minus y is nothing, and 12 minus 3 is 9. I don't have anything else to bring down, so that's my remainder, 9. But we don't ever leave it just as a remainder 9. We make it a fraction over the divisor. So my final answer is going to be y plus 1 plus 9 over my divisor, y plus 3. So when I divide y squared plus 4y plus 12 divided by y plus 3, my answer is y plus 1 plus 9 over y plus 3. Because 9 was my remainder, and you'll remember from long division, we always took our remainder and made it as a fraction over the divisor. That's exactly what we're doing here. Here's the next problem we're going to look at. 3x squared plus 9x minus 15 divided by the quantity of x plus 5. Now again, I'll just tell you to trust me. I cannot factor 3x squared plus 9x minus 15 into two binomials, so I'm going to have to use long division. So I write it 3x squared plus 9x minus 15 underneath, and x plus 5 on the outside. So once again, I'm going to just take the 3x squared and the x, and we're going to deal with those. So 3x squared divided by x is 3x, and it goes right here. Because x, put them all in line. So 3x times x is 3x squared, and 3x times 5 is plus 15x. But remember, I have to subtract these. So I know that 3x squared minus 3x squared is nothing, and 9x minus 15x is negative 6x. Because 9 minus 15 is negative 6, 9x minus 15x is negative 6x. And then I bring down the negative 15. Once again, I'm going to go back and just look at the first term. What's negative 6x divided by x? And that would be negative 6. So negative 6 times x is negative 6x, and negative 6 times 5 is negative 30. Again, I'm going to subtract these, and I know that negative 6x minus negative 6x is 0, and negative 15 minus negative 30 is positive 15, because negative minus a negative would be negative 15 plus 30, which would be 15. If you don't trust me, use a calculator. If you need to use a calculator, use a calculator. So my remainder is 15, but I don't leave it as the remainder. I don't have anything else to bring down, so I just write it as 15 over x plus 5. 15 is positive, so it's plus 15 over x plus 5. So my final answer for this problem is 3x minus 6 plus 15 over x plus 5. Our next problem that we're going to look at is 9n cubed, notice the cubed, minus 13n plus 8 divided by the quantity of 3n minus 1. Now, you'll notice as you look at that 9n cubed minus 13n plus 8, we're missing something. We're missing the n squared. And it's okay that we're missing the n squared, but we have to leave a space for it under the division symbol. Here's what I mean. When I write 9n, I'm going to write it a little bit lower so I remember at the top. 9n to the third, I have to leave space for the n squared. So I'm going to leave some space. We're not going to put anything there, but I'm just going to leave some space. And then I'm going to write 13n plus 8 divided by 3n minus 1. I have to have space for whatever exponents are lower than my first one. So I've got n to the third, I've got to have n squared, n, and then no n at all. I have to have space for it. If there was one there, then I'd put it, but since there's not, I've got to leave space. Here's why. 3n goes into 9n cubed, 3n squared times. That's why I have to have this empty space, because I can't put the n squared over the n. That doesn't work. So 3n squared times 3n is 9n cubed minus 3n squared, because 3n squared minus 1, times negative 1 is negative 3n squared. Here's the tricky part. 9n to the cubed minus 9n cubed is 0, but 0 minus negative 3n squared is positive 3n squared. I'm going to say that again. 0, which is essentially what's here, minus a negative is going to be positive. That is key. 3n squared, I bring down the minus 13n. So how many times will 3n go into 3n squared? Exactly, plus n times. So n times 3n is 3n squared, and n times negative 1 is negative n. Again, we got to be careful in our subtraction. 3n squared minus 3n squared is nothing, but negative 13 minus negative n is negative 12n, because it's negative 13n plus 1n, which would be negative 12n. And I bring down my plus 8. Same process. How many times will 3n go into negative 12n? Negative 4, so I have to put a negative 4 right there. Okay? Because 3n goes into negative 12n negative 4 times. So negative 4 times negative 3n is negative 12n, and negative 4 times negative 1 is positive 4. Again, I'm subtracting. Negative 12n minus negative 12n is nothing, and 8 minus 4 is 4. So my remainder is 4, but I can't just leave it as 4. I have to put plus 4 over my divisor, which is 3n minus 1. So my final answer is 3n squared plus n minus 4 plus 4 over 3n minus 1. Again, you won't have very many of these problems, but I just wanted to show you the process. If I'm missing a variable, then I have to leave space for it. Okay? If this was a 9 into the 5th, then I have to have a place for into the 4th, into the 3rd, into the 2nd, into the 1st, and then nothing. But since it's an n 9 into the 3rd, I just have to leave space for n squared, because I have an n. Okay, I hope that wasn't confusing. Just know you have to leave space under the divisor for all of them. So here are your two practice problems for this video. They're both using long division. The first one is n squared plus 6n plus 2 divided by the quantity of n minus 2. And the second one is 4n squared minus 3n plus 6 divided by the quantity of n minus 2. Notice I didn't leave out any exponents. Everything is there that you need to, just long division. When you're finished, please take a picture of the entire problem, not just the answers, and submit those on Edmodo before class starts.